It is April 18 around 2:30. So yesterday we completed the rest of the land that needs to be harvested, and this was the last one to be harvested yesterday, the 17th of April. Last year, around August 2023, second crops, I wanted to understand why the yield, the estimate yield, is not following the actual yield. So I noticed that in the case of Basao, I didn't have the estimate because I didn't have the panicle count and the square meter sample. So anyway, I had enough data to actually get some meaningful value, and I was seeing. So I have the estimate, and then the actual yield is half. So I wondered why. It doesn't make sense. I had the idea that the actual yield would change uh, from 0.5 to 0.8. It actually had a trend, and although at the back of my mind I realized there is a trend, or there was a trend, I didn't get a sense of that trend until I had more data. So these are the area in square meter. So Amyanan, which is north of the house, is 56,000 square meter, and I have this data. So per square meter, I was getting 1.1 kilos. If a farmer is getting less than 1 kilos, it's going to be a challenge. No matter what you do, it's going to be low yield based from my sample. So I've seen a lot of people uh, on video in YouTube, and their sample size per square meter, they were getting like 0.7 kilos per square meters, zero point 0.8, and they were happy with that data. Now, for me, not knowing any better without data, otherwise everything is an opinion, I thought, oh, that's all right. Anyway, it turned out that anything less than 1 kilos is it's a problem. A farmer should be getting over 1 kilo per square meter. So in C2 2023 or second crop 2023, I have 5 areas with five locations with different areas, giving me these values. So I have the estimate in kilograms and the actual yield in kilogram, and I'm getting this yield factor. So what is this yield factor? It's basically this number L4 divided by this number, okay, I4, okay, I4 L4. So I'm seeing a trend like around zero point 0.5. So as you can see, there is a trend here. Now in first crop 2024, I have 1, 2, 3, 4, 5, 6 places, and the per square sample varies from 1.1 kilos to as high as 1.96. Now, in the area of Muñoz, because I had planted these four variety, Brigante, Asalate, Longping, and RC436, I have these varying values, and I average them to be 1.62. So for 70,000 square meter, my actual yield is 51 tons. And of course, the yield factor is giving me, using this data, is 0.46. I average all of these and it gave me 0.48 as the yield factor. So I took this and plot charted. Now these data are just data. You might say they're almost random. However, these random numbers have a trend. And so I took this data and created a new table. So these are the table. Estimate yield based from this value and the actual yield. These numbers are just that number. I didn't format them or anything like that. So I plot chart them. So basically, to start, let me just delete this. So how do you plot chart? Take this data, insert, take these, scatter. Okay, as you can see plots. Okay, move them out of the way, move it out of the way, not dead. Make it larger, and then take any point and add trend line. Okay, set the intercept to 0 because there is no plus or minus kilograms, so the intercept is 0. And set it for linear because you could set it for exponential. Nothing. Logarithmic. Eh, it doesn't work. Polynomial. It sort of work maybe. It could. Power. Moving average. But linear is. And set the display equation on chart. Display the let's see, determinant value. And let's see here, what? Why is there an offset? I set it to 0. So let's see here. I'll have to do it again because there is an offset. I'm not getting like 675 kilos right off the bat. So it needs to be set to 0. So I did something wrong. So do it again. Scatter chart. Make it larger. Okay. Add trend line. Set intercept to 0. Linear display. Move that out of the way. Okay, I guess I can't make it any bigger. Anyway, so the value, the trend value, y is the yield, close to actual yield. And when you look at r, which is, let's see here, what is it? What is r means? R is a determinant or determination. It's called coefficient of determination. The closer it is to 1, the better the trend, meaning that it matches the trend. So now, using the value 0.4575, sorry, here, then from estimate, these two values, the actual yield and this, they come pretty close. They actually come pretty close. Okay, so 27,000 tons or 27 metric tons, 28 metric tons. What's plus or minuses, and it's pretty close. I mean, you can nitpick. I mean, the highest could be like 1 ton difference. Now I use 0.48. So with 0.48, it's a little bit higher with this two. The 0.48 yield factor. You're getting a little bit higher. Okay. And this one, yield factor of 0.575 or 73. Okay, whether you use that or this, because you're dealing in tons, and and a farmer is simply looking at this data. He says, does it make sense? I mean, take a look at this one, 51 tons, and this one is pretty close. They're about the same, you might say. This and this using 0.48 yield factor, this and this is about the same. So you can use 0.46 if you want to do a two significant figure right of the decimal. Since I've averaged that to 0.48, but the equation or trend is 0.45. So, and based from other data, I mean the lowest is 0.36 and the highest is 0.56. So that is the range of factor one could use. So now understanding what it means over time, as I do this, I would also start inputting data for second crop 2024. For example, I've started to tabulate certain things. So for crop second crop 2024, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 locations, and I would have more data to work with, figuring out what it is that I need to work upon. So what does it mean, this data? And what is this trend means? To me, this trend means this is natural. It's not something I made up. It's just natural. It's the way it is. Um, I couldn't fight this data because it's actually actual data. And what can you do with this data? The thing that you can do with this is you look at this particle count per square meter, and you want to be able to increase the mass or kilos per square meter. Ideally, you want to go up to close to 2 kilos. So, for example, 2 kilos, what is 2 kilos be? So, if you do calculation, okay, so 2 kilos per square meter, you want to do this, equal 2 kilos times 10,000, okay, that's your that's the tons. So 20 tons. 1 hectare is 20 tons. Well, you're not going to get 20 tons in 1 hectare with without doing any changes to your method and procedures. So anyway, what would be the actual yield? The actual yield would be multiply this by 0.4575. So basically, at the end of the day, when you harvested, you would get pretty much half of it. And here, if I use 0.475, or if I use uh, 0.48, okay, I mean there's an increase in kilograms by by about 400, 450. So quite frankly, using 0.48, 0.4575, it's a give and take. So my advice to those who are doing estimates, you have to look at your own data. I mean, if you only have one location, okay, you have one location, you do your samples, these would be about around that, about the same. For example, 10 tons. And then your actual yield would be varying. And then you can do an average of your yield. Like you'll see a trend. It might be groupings. It will be a group. For example, here it'll be a group. It'll spread out a little bit. However, if you do a trend, it will give you about the same. And if you have different areas, you would have different groups like these. So you can see this one, it's below the line, and this one is above the line. So you can this is actually 1.96. So that's how the data falls. It's not something made up. It's the nature of things, and I accept it. It's quite interesting that I would see this. I wasn't expecting to see this. So it's a surprise, and also at the same time, is it really a surprise? I mean, estimates estimates is quite huge, and then your actual it's quite half, and you ask yourself why. The answer is it is. It's the way it is, and it's there's nothing much you can do about it. Now, what what I wanted to communicate is if your kilos is less than 1 kilograms, which I saw in many places in YouTube, their kilos was one YouTube in particular. His average was 0.766 kilos. Now, honestly, in that and per square meter, so he has 1 hectare. So it is to the number. So 0.766 times 10,000 square meter. Now he would be getting 7 tons. What's the actual yield on 7 tons? It would be this times 0.48 maybe, or this times 0.4575. Okay, what is that in kabans? Well, and normalize at 50 kilos. Okay, 50, normalize 50. It would have 74 kabans. And what's this? Normalize at 50. So the difference is 3 kabans or whatever. I mean, like I said, what's what's 1 or 2 kabans when you're doing estimates in tons? So now another guy, another YouTube that I saw, his average, he took 3 samples and his average was 1.2 kilos. So what is 1.2? So 1.2 times 10,000 square meter. So his estimate yield is 12 tons. What is it using so it's around 6 tons. So again, if you notice, no big deal. Now what is that in kabans? Okay, normalize at 50. So 115. So 110. Around 5 kabans difference. So when you're dealing with samples, you have to look at the data. And what I noticed on these two YouTubes, one was done a year ago, the other one was done 3 years ago. It would have been nice for them to update their actual yield. What I've noticed is there is no data on actual yield. And I think you or one can infer why they wouldn't update their YouTube to tell people who's watching what's the yield, actual yield. It's because their excitement to saying, oh, I'll be having 7 tons or 5 tons, it falls short. It really will fall short. It'll be half of their expectation. Now, for me, I knew from the onset when I started to look into this that there is a factor. I would call it correction factor. It's not a calibration factor. Correction. I decided to use estimate instead. I decided to use yield factor. Sorry, misspoke. Because it's the way it sounds. Yield. I'm looking for yield. And this is what it looked like. It's not made up. I've gathered data I will be gathering more data as the years come, and fill in this. It will spread, or uh, or in type grouping. However, even in type grouping, it would still have a trend, and and that trend would be this, or a change of value. Maybe the 0.4575 would change to 0.47. I don't know. At this point, I'm satisfied with this data, and it will help me to move forward in understanding how a person or a farmer can improve yield. The main thing is a person, a farmer, should increase their the kilos per square meter. Being happy with one, less than one, is not a starter, it's a non-starter. Be happy with 1.2, really is. And getting there is something that a farmer should understand and learn. How do we get from less than 1 kilos to 1.2, even better to 2? So those people who are getting 300 kabans, 250 kabans, what is that really in in terms of 1 square meter of sample? So let's do some numbers. So suppose 300 kabans, okay, that's 1 hectare, times, let's see, 300 kabans times, normalize it at 50 kilos, okay. So 1 hectare will give you 15 tons. Okay, what does that mean in per square meter? Okay, so take this number, divide it by 10,000. Okay, so your the square meter sample needs to be 1.5. Okay, now why didn't I get 15 tons since I have 1.5 of this? Okay, because the average of these two samples right here is 1.36. This is not giving me 15 tons. Why? Because when you look at samples, there is, when you're looking at 10,000 square meter, all over, it doesn't mean 1.5. I mean, it's just a place that I picked and it gave me 1.5. However, if you sample the 10,000 square meter, all of it, which is harvesting it, this actually will give me almost 10 tons. I'm off by 5 tons. Why? I don't know the answer yet. As I progress through this discovery, I would understand why 1.5 kilos does not equate to 9 does not equate to 15 tons. Why? Okay, so 300 kabans normalized at 50 gives me 15 tons. Okay, I divide that by 10,000. It gives me 1.5 kilos per square meter. Okay. This 15 tons, I have the same thing here, but I have around 10 tons. I'm missing 5 tons. Why am I missing 5 tons? That is the question that I'm going to answer in the next several years, because I don't know. I actually don't know the answer. The thing that will come through though is as I gather more data, I would begin to understand how I'm going to sample my data. Okay, this data, I just went to the right to the field. I just went and took 1 square meter. That's it. I did all of this, and the sampling is whatever. And so because it's whatever, it's just the way it is. Maybe I can improve upon the my sampling. However, 1 square meter. I mean, with the thread, I don't know how this would trend. In fact, by by achieving this 15 tons, 1.5 kilos per square meter, this trend would change. It probably goes like this. Okay, it will change. So I will have that data over time, and that's it. I hope that people, farmers who are watching this, understand this data. It's a lot to take in. Um, Also, you could help out by sending me data, your sample, 1 square meter sample, okay, and the rice breed, and then give me the actual yield in kilos. Okay, by this data, I can get estimate. What I'm interested in is the actual yield. I would add it to the table here and get a trend. It'd be really interesting how this trend would come about. I mean, the 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 thing that I'm really interested in are these farmers that's getting 15 tons per hectare. I really like to see what their data look like. I would like to see their panicle count. I would like to see their square meter sample. If they do this, and if they do this, get these two data. Okay, now from this data, what is the average mass of a panicle? These are the average mass of a panicle. In fact, let's see here, if I do this, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the average of a panicle would be 3.6 grams. Let's just kill it for, let's just call it 4 grams. Okay, so the the more mass a panicle has, the more kilos in actual yield. Like this, panicle count per square meter, so it varies. It'd be nice to know. Be nice. I can get, once I get this, I get this. So give me panicle count, sample in square meter, and this. I can do the rest. It's really easy. It's all math. And I hope it's helpful to you, the farmers that look at this and say, yeah, I get it. It makes sense. I'm getting a sample. I calculated the estimate yield. However, I'm actually getting half of it. Why? That's what I asked myself in second crop 2023. Why? I didn't have enough data. So now I have lots of data that would help me determine uh, the trend, the yield factor, it could improve, it could be higher, like it could be like 0.5. I doubt that it would go 0.6. It could be from 0.3 to 0.58, something like that. I don't think it'll even get to 0.6. So, I mean, if you look at a number, let's see here, 20,000. Okay, let's say 20,000. I'm using 0.6 as a factor. If this number instead 0.6, and then 0.6, it would be 12 tons. Okay, so what is that? What does that mean in 12 tons? Well, it's pretty close to 300 kilograms. Anyway, let's just continue with that. 12 tons divided by 50, normalize that, 240 kilograms. So I doubt that it would go to 0.6. It would somehow this would swing up, I mean around the zero axis or origin. I can't see that swinging yet uh, without something happening. So anyway, the goal I have is per hectare 15 tons. That's my goal. Normalize at 50 kilos, 300. I'm happy with that. Right now, I'm not happy. Okay, this is silly. I'm happy in a way that I understand a few things. However, I'm getting 1.5 kilos per square meter, and yet I have this around 10 tons. It would be nice if the yield was 15 tons. Oh well, this is fun a minute with this data. I hope that a person watching would say, "Yeah, Ezekiel, I get you. I get the same thing. Uh, I would love to see your data, YouTube watcher, what you're getting. It really is something to be helpful. Give me your data. I'll input it. I'll add it to my data and get additional data. It's just need the final count, kilos per square meter. Give me your actual yield. Okay. Oh yeah, and give me your square meter. So, what do I need? Area. It doesn't even matter. Just give me. I'll just assume 10,000 square. 1 hectare, 10,000 square meter. I need. So I'll assume it to be, for example, 10,000 square meter. Conical count, mass per square meter, and then the actual yield. Three things. Send them to me. Uh, yeah, it'd be a nice additional data that I can use with and improve this this factor. I mean, I could probably see 0.56, 0.58 maybe. It'd be great if it goes up to 0.56. Actually, what would be the ah to get 15 tons? 15 tons. If I work backwards, okay? So work backwards divided by 0.4575. Per square meter, it would be like 30. their yield factor would be like 32 tons. It would be like having 32 tons here and actual yield to be 15 tons. See, working backwards. I'm nowhere near that. Nowhere near. And that's the way it is. I mean, I wish it was. Now, there's something that I'd like to communicate. So, Mormon, 10,000 square meter, NK, actually this is NK 6003 breed type. Okay. I have, the sample is 377 uh, panicles of color, and the mass is 1 square meter. It's 1.6. I mean, it's higher than 1.5, obviously. So the thing about this is my estimate was 16 tons. Okay, 10,000 times 1.6. The thing that I just want to show is that it's half of the estimate yield. Okay. Now, when I look at the overall area, there's a few places that really aren't the same as my sample, and so that's the reason why it's this. What does it really mean? It means that the panicle themselves, uh, there's a lot of panicles or spikelet that hasn't fully developed. So and those are thrown out. I noticed. I was watching the harvester go through uh, the area. But one thing though is this breed here. It really is interesting. So I'm going to replant this next year, MK 6003. So it's I think it's really a good price to plant. I mean, it's better than Longping, better than SL8. Okay. So here in Muñoz, I have Gigante, SL8, Longping, RC436. My average is 1.6, and the estimate is 113 tons, but my yield is 51 tons. So it's half, around there. So how? So now that I know all of this, I need to understand how to improve this so that it could be like 15 tons per square meter. Thanks for watching.